So I wanted to do a video on the multiplication rule of probability. We use this when we want to find out the chances that both events will happen. So, for example, the probability of drawing a blue or green marble out of a bag of marbles. This here is the formula, and it says the probability of A and B happening equals the probability of A times the probability of B given, that line means given, A happened. So let's say we have 12 marbles in total. 3 of them are green, 4 of them are blue, and 5 of them are red. What we get is that, let's say the probability of green, right, is 3 out of 12, because there's 12 marbles, 3 green. Then the probability of blue marbles given green marbles is 4 out of 11. We say 4 out of 11 because there's 4 blue marbles, and we say 11 instead of 12 because we're assuming that we didn't put the marble back in the bag, so we have to take one away. So now the probability of green and blue is 1/4 times 4/11 equals 4 out of 44, ultimately equaling 1 out of 11. So because we didn't put the marble back in, this is an example of two dependent events. This formula can also work for two independent events. So let's say if we would have put the marble back in the bag, the probability of putting a green and a blue after replacing the green, like I said, we're putting the marble back in the bag, we would get the probability of green is 3 out of 12. The probability of blue is 1/3, and then we multiply them, and we get 1 out of 12. Okay, that was a more simplified example. So now I took a question from your little in-class assignment and walked it through. So the question says, use the data in the following table which lists drive-through order accuracy at popular fast food chains. Assume that orders are randomly selected from those included in the table. If 2 orders are selected, find the probability that they are both accurate. Okay, so assume that the selections are made with replacement. Are the events independent? So the important part here is this right here where it says with replacement. So let's say A equals accurate and B is going to equal not accurate. This is actually not important. Don't worry about this. A equals accurate. So we're going to say, since we are using with replacement, we're going to say that the probability of A equals the sum of the accurate orders. So all of these over the total number of orders. So all of these. So that's 963 over 1,110. You don't have to put it into a decimal. I just did because I don't know. Because it's asking us the probability that both are accurate with replacement, we multiply them together because it's asking us the same thing. For both of them, are they accurate, not whether it's blue or green. If it was like that, it would we'll multiply both those probabilities. But since it's asking us for both are accurate, we just multiply these two together. Notice that this one is not one less because, again, like I can't stress it enough, it's with replacement. We're putting it back in, and what we get is this number at the end. Again, this is important. The event are independent because it is done with replacement. They always go together. Independent, replacement, dependent, without replacement. So the next question is, assume that the selections are made without replacement. Are the events independent? So we go back and we use the other formula. We had the probability of the two events equals the probability of an event times the probability of an event happening given the other event. So right now we just put the probability of A and A happening, right? Both, because both are accurate. We want to know what's the chances that both will be accurate. So the probability that both will be accurate equals the probability that it will be accurate times the probability that it will be accurate given that it will be accurate. So we already did the probability of it being accurate, 963 over 110, or 1,110. And then the probability of A happening given whatever. What we get is 962 over 1,109. So I get this from subtracting 1 from here, because we are not replacing it. We have to take it 1 away from it. So when we multiply them together, we get this number. So the events are not independent. They're not independent because it's done without replacement. Let me know if this helps and if you have any questions.